All right, I'm back, and now we want to continue our discussion of pulleys. So I've redrawn the pulley over here. So this was our first pulley that we worked with, and it wasn't really much of a pulley. So all it did was it changed the direction of the force that you applied. And then down here, we've got written the formula that we're going to be using. The force that you put into the pulley multiplied by the distance, the amount of rope that you're pulling on the pulley is going to be equal to the load that you're lifting, and then how high are you lifting the load. So now what we're going to do is this one. So in this case here, we're going to have a rope. It's going to go over the pulley. It's then going to go under another pulley, and then that rope is going to be attached back to the original pulley. And so if we go back to this simulation here and we hit reset, okay, now we're back to the original setup, and now we're going to click on the second one. We're not going to do this one, okay, but this is a double pulley, and you can see it goes over one pulley, then over another pulley, and now you're going to be pulling down on it. You should be able to predict what's going to happen. So notice that that pulley system is very much similar to this one over here. The only advantage of that pulley system is it gives you a further distance away from the box, sideways, that you can apply your force. But other than that, it's not really all that exciting. So now let's try the next one here. Okay, so here's another configuration where this time you're going to be pulling up on the rope and lifting the box. So we're not going to do this one. So let's go now to this one. Okay, and now this one is this one here. So you're going to, so the rope that you're going to pull is on this side of the pulley system, but it's the same picture as this one right here. Okay, now how are we going to figure out mathematically how much force are you going to need to pull on the rope with in order to lift the box? Now notice that the weight of the box is still going to be 10 newtons, and the height that you're going to lift the box to is still going to be 0.14 meters. So that's going to be the height right here that you're lifting it. Now what you need to know is how much force in do you need to apply to the rope, and then how much rope do you need to pull. That's going to be the distance in that equation. So how can you figure it out? All right, so think of it this way. If you've got let's say it's a trash can. So here's a trash can, and let's say that the trash can weighs 100 newtons. So it's pretty heavy. Now if you, by yourself, lift on that trash can, how much force do you need to apply? 100 newtons. Okay, you're by yourself. But what about if there were two people? And so one person grabs the trash can over here, and then the second person grabs the trash can over here, and you're both lifting it. How much force do you think you each need to apply? So the total force going down is 100, but you've got two forces pulling up. Do you remember when we talked about statics problems with forces? And we said that these would be positive numbers. So let's just say that this is F. So this is the force that this person's going to apply. And let's assume that this person over here also applies the same amount of force. we did a statics problem in which we said that the sum of the forces pulling up has to equal the forces that are going down. Or we could say F, positive F, because it's going up, plus positive F, because it's going up, and then minus 100, because it's going down, that force is pulling down, has to equal 0. So the sum of the forces on a system is going to be equal to 0 if it's in static equilibrium. So what's F plus F? Well, that's going to be 2F. So now we got 2F. Okay, what about if I take this 100 and I put it over here? So then that would equal 100, and then 100 divided by 2 is going to be 50. So can you see that each of you needs to pull up with 50 in order to lift 100? Who cares? Look at the ropes in that picture over there. Do you see that there's one rope over here and you got one rope over here, and they're both lifting what? They're both lifting the 10 Newton weight. So therefore, can you figure out how much force do you need to apply? So if two people were able to lift 100 newtons by each applying 50 newtons, then if you want to lift 10 newtons, then each of these ropes needs to be applying what? 5 newtons. So you'd have 5 newtons over here, and then you'd have 5 newtons over here. Well, look at where this rope goes. So, well, this rope. So this rope goes over to here. So that means that you only need to pull with 5 newtons of force, and then you'll be able to lift 10 newtons of force. So what do? Count the number of ropes that are physically attached to the weight. So you got this rope and you got that rope. Now I know that you're saying, well, what about this rope up here? Well, this rope is really this rope over here, so it doesn't count. So there's 2 ropes holding up the weight, and then each one of them is going to be a 5 newton. So you only need to apply 5 newtons of force. But you can't get something for nothing. So what's the disadvantage? So if it's only taking 5 newtons of force, that's the amount that you're putting in, and you're going to need to pull a certain amount of rope in order to lift it. Okay, now on this side over here, what do we got? 10 newtons of force, and then you're lifting it 0.14 meters. Okay, so let's solve that for the letter R. And you would find that you're going to need to pull 2 times this distance. So that's going to be 0.28 meters. So that's going to be the amount of force that you're going to need to apply. So the good news is it takes less force to lift the weight. The bad news is you're going to have to pull more rope in order to do that. So let's test it. So we'll go over here and we'll grab the handle. We'll pull it down. Nothing's happening. But once we get to a certain distance, okay, did you notice that in order to lift the box 14 centimeters, do you see that this distance here down to the hand got bigger? And then you could take your ruler here and you can measure that distance, and it turns out to be 28 centimeters or 0.28 meters. And then also take a look at the amount of force. So the amount of force that you had to apply this time was only 5 newtons in order to lift this 10 Newton thing. Okay, so pulleys are pretty cool. Now, also remember, think about a pirate movie. So, in a pirate movie, uh, you have old-time sailing ships where you had the sails could weigh tons. Okay, we're talking about thousands of pounds, thousands of newtons of force uh, that was hanging from the rigging. But yet it showed a single sailor being able to lift all of that cloth into the air. But did you notice what they were doing? They were pulling lots and lots and lots of rope in order to be able to do that. So, yes, they were increasing their force, but the bad news was they had to have a lot, pull a lot of rope in order to do that. All right, let's take a break, and when we come back, we will do our third pulley system.